Okay, we're going to do a couple problems where we are maximizing revenue. The first one here says the revenue function for a particular product is R of X equals X times the quantity of 4 minus, it looks like 0.0001X, so I think that's a 10,000th X. Find the largest possible revenue. So let's see here. First of all, I'm going to write down my function, which is R of X equals X times 4 minus 0.0001X. And while this is not necessary, just trying to relate it back to the actual revenue function. Remember, revenue equals price times quantity. I think in this case, this is probably written as quantity times price, because I think if you tried to dissect this, you would be thinking about X as the number of things you sell, and the other part being the price. I'm not sure. We really don't know what this function is doing. But let's see here. So if we're going to take a derivative, probably the best thing to do is get rid of this product. We could use a product rule, U times V, X times this other thing, but we can just distribute that X through. So let's do that. We'll just rewrite the function. It'll be 4X minus 0.0001X squared. And then we need to take a derivative. So R prime for our derivative will be 4 minus 0.0002X. Okay, so we took a derivative, but remember the derivative gives a slope. Okay, the derivative gives a slope. And we want to figure out where this thing is turning. So if this thing has a largest revenue, it must have a max. So we're looking for where that slope goes to 0. So I'm going to set my derivative equal to 0. So 0 equals 4 minus 0.0002x. I'm going to bring the 0.0002x over to the left-hand side and divide it out. So I'll write it 0.0002x equals 4. When I get down here, I get 4 divided by this number. So let's see. 4 divided by 0.0002. I get 20,000. So let's kind of go back and read our problem. It says, find the largest revenue possible. What we found was the X, which would be the quantity that gives us the revenue. So to actually get that max revenue, we want to take that 20,000 and plug it into our problem. Our original. Remember that R, the original function, gives us the revenue, where R prime, the derivative, gives us how the revenue is changing, which is not what we want. So let's see here. I don't think I have a lot of room here. Let's see, 20,000 times 4 minus 0.0001 times 20,000. Yeah, I'm going to run out of room there. Sorry. It looks like I moved something here. Anyway, it's running off the page. I'm sorry. Let's see if I can move it while we talk here. Yeah, I can. It won't let me write off the page on my tablet, but it will. Put it there. There's a 1 here. Anyway, let's kind of work that out. So we got 20,000 times 4 minus 0.0001 times 20,000. Ooh, a little bit of a error there. 4 minus 0.0001 times 20,000 gives me 2. That's what I thought. So basically, I think I'm selling 20,000 items at $2 a piece. But this revenue, when X is 20,000, looks like it's going to be 20,000 times 4. That would be 40. 20,000 times 2, that would be 40,000. So basically that means if I sell 20,000 items, I have the most revenue I could have at $40,000. So if I sell 19,000 items, I will make less money. If I sell 21,000 items, I will make less than 40,000. Now the reason for that being is that as the quantity increases, I have to lower the price, so there's that offset point. Let's see what the next problem looks like. The demand equation for a product is P equals 2 minus 0.001x. So that's the price is equal to 2 minus 0.001 times the quantity. It says find the x value and the corresponding price that maximizes the revenue. Okay, so we need a revenue equation. So we're going to go with revenue. And remember, we just talked about it being price times quantity. Or quantity times price, it really doesn't matter. But if we say price times quantity, it could be 2 minus 0.001x, that's the price, times the quantity, which would be x. So we'll just continue that out and multiply it. So 2x minus 0.001, getting ahead of myself, x squared. So that's my revenue equation, and that's what I want to maximize. I want to maximize revenue. Okay, so that's why I'm working with that. So I need a derivative because that's going to allow me to figure out when it reaches a high point and turns. So the derivative will be 2 minus 0.002x. Set that equal to 0. And solve it. I get 0.002 divided into 2. So 2 divided by 0.002 gives me 1,000. So says find the value of x. So x equals 1,000 items, whatever they might be, and the corresponding price. So the price will be P equals 2 minus 0.001 times 1,000. So that price will be $2 minus $1. So we're going to sell 1,000 items at $1 per unit. Now you can imagine that means we have a revenue of $1,000, but they don't quite ask us that. They ask us to find the X and the price. Okay, let's see what we got down here. A certain toll road averages 36,000 cars a day when charging $1 per car. A survey concludes that increasing the toll will result in 300 fewer cars for each cent of increase. What toll should be charged to maximize the revenue? So they're asking us for the toll. So remember, revenue equals price times quantity. And this is not the easiest problem in the world to set up if you're not used to them. Sorry, I keep jumping around there. But we're going to have R of X equals. Now our price starts at $1. And it's going to increase. And we'll talk about that in a moment. Our quantity starts at 36,000. And it's going to decrease. So we're trying to set up what we think is going to happen here. So it says for every cent we increase the price, the quantity goes down by 300. So what can we do with that? We could come over here and we could say that means 1 plus 0.01x. That's adding a penny, x times. We're going to lose 300 cars x times. So 1 plus 0.01x, that's the price part, how it's fluctuating. And 36,000 minus 300x, that's how the quantity is adjusting. So we need to full that out. So that'll be 36,000 minus 300x plus 360x minus 3x squared. I'll rearrange that before I take a derivative, but I get negative 3x squared plus 60x plus 36,000. So that's my revenue function based off of the adjustments here. So my derivative will look like negative 6x plus 60. So I want to put that equal to 0 so I can find where it's the largest. So negative 6x plus 60 equal to 0. Solving that, 6x equals 60, so x equals 10. So I'm going to, basically that's the number of times I'm increasing the price. So if I come back to the price, the toll here is the price that we're charging. We've got an x value here. So this price, toll or price, equals 1 plus 0.01x, and our x is 10. So that'll be 1 plus 0.10. Sorry. So the toll for the max revenue will be $1.10. I don't know why it looks so weird when I write it. But the $1.10 toll per car will be what gives us the most revenue. And we could figure out what that revenue would be if we wanted to plug the 10 back into our revenue equation. Thank you.